Hello, everyone. Happy November. Welcome to EECS 494 Discussion 10. We've done 10 of these now, which is pretty cool. I know it's been a stressful week, so hopefully thinking about Unity will de-stress you. It's unlikely to, but let's let's do the discussion today. So this is another student request, actually. We're going to talk about the canvas and like UI elements and different things you can do to make like dynamic and responsive and like juicy UI components, or at least things you can consider when you're doing it. I'm gonna try and just give you kind of some guidance and not really tell you what to do here. So to start off, I want to mention the idea of anchors, which are kind of a key component to how the canvas works. So you may have noticed that in the Unity editor, let's say I add a UI element, I'm going to add a text element. If you look at it in this rect transform here, this is the equivalent of like a transform for a game object. Canvas elements have what's called a rect transform. There's this little square here that says middle center when it starts off. You can basically select this to be anywhere. These are all these presets. You can also set the anchor to be any position you want on the screen. But what is the anchor? It's essentially what it does is it tells this UI component what the 0, 0 coordinate is and what direction is positive x, positive y, and positive z. So essentially, what that the reason for thinking about your anchors is for different screen sizes. Um, it will always be positioned relative to the anchor. So, for example, if you have a UI component that you want to appear in the top left corner, and you want it to always be in the top left corner for all screen sizes, what you're going to want to do is select the top left corner here in the anchor presets. I'm also going to press and hold Alt and Shift and set its pivot and position also to the top left corner. Now you can see it's been moved to the top left corner, and if you look in my position is 0, 0, 0. So you can see that 0, 0, 0 is the top left corner, and if I resize the screen, if I change the aspect ratio, it's always going to be in the top left corner. This is in comparison to, let's say I make the position the center, like the anchor the center, and then I simply just move it to the top left corner using positioning, which is something that you might conceivably do because if you're not aware of anchors. Then what happens is if you resize the screen, since it's positioned relative to the center of the screen, resizing the screen will just be causing you issues where it disappears and it's not at all what you want to happen. So that's kind of a primer on what anchors are, and you should it's once you know what they are, they're not too difficult to reason about. Just pick the anchor that's closest to where the thing is going to be. Think about, try to think about your UI elements in terms of, quadrants and center of the screen rather than like absolute positions. And when you do that, then, picking your anchor will definitely be a lot easier. And, I would recommend keeping that anchor picked and going with that when you're designing your UI elements. So, all right, let me move this back to the center. Actually, I'm going to move it to the top here. Um, So that's the anchors of Rectangle. They're pretty important things for making UI elements that work well on other big all screen sizes. The other part of making UI elements that work on all screen sizes is to change this to scale with screen size. in the main canvas game object, go to canvas scaler and set the UI scale mode to scale with screen size. What this will do, especially if you're going to lock the aspect ratio of your game, which I would recommend choosing the 16:9 aspect ratio for your game, which is the most common aspect ratio for screens. And if you want to offer, windowed versus not windowed and different resolution types, which isn't a requirement for your game, you have no requirements to do this for P3. But if you are, I would if you want to make it like the game has a customizable resolution, I would suggest. I mentioned this on Piazza. I would recommend picking a couple aspect ratios to support, or just one aspect ratio to support, and then sizing based off of that, because you can see the way that scale with screen size works. If I do this, it will scale down, which doesn't look great, and I'm not sure even then if you want players to be playing with a square screen, unless you're designing a game around having a square screen size. So let me lock this to 16:9. The Unity, the game window, the game tab, has the ability to pick aspect ratios to work from. So I'd recommend taking advantage of that when you're fixing your UIs. Anyways, the next thing I wanted to discuss, let's check if there are any questions. Nope. The next thing I wanted to discuss is these interfaces. There are 4 interfaces I wanted to mention. Oh no. Let me disable my phone notifications real quick. I apologize. Okay, sorry about that. These interfaces are part of the Unity Engine.Event Systems namespace. But what they do is they let you implement functions for when UI elements get hovered on or clicked on, or the hover stops or the click stops. And in terms of, responsive, juicy user interfaces, this is probably the biggest thing that you want to have access to, so that you can respond to the user input in some way with your UI elements. So I wanted to kind of show you how to use these interfaces to handle these things. In just a brief example, and then talk about it further after that example. The last thing I wanted to note before I get started is Text Mesh Pro. You might have noticed when you right-click or you click plus and then you go to UI, you have the option for text button drop-down input field of like Text Mesh Pro versus not Text Mesh Pro. Text Mesh Pro is essentially like a nicer text thing that is better than default text. It's less blurry when things get resized. It's got a lot more control in terms of scripting. It's got rich text support. And one thing that's really nice is you can apply surface shaders to them. So if you want the lighting in your scene to affect your text, you can make that happen, which is pretty cool. So I would recommend thinking about Text Mesh Pro when you're making your UI elements, as it might be nicer. Okay. Anyways, let's get started. I'm gonna have this text up here. I'm actually gonna move it down a little bit. Let's make it 30. Let's increase these numbers a bit. I'm gonna make it 500 by 100. And then I'm gonna make the text centered. In terms of horizontally, I'm gonna say main menu. And then, so I'm just gonna say main menu, and I guess I'll increase the font size a little bit. Let's make it, let's not do underlined or bold. Let's just make it bold and underlined. Cool. Now I'm gonna right click, I'm gonna go to UI, I'm gonna add a button. Oh no, I wanted to add a text mesh pro button. Sorry, UI button text mesh pro. One thing I personally like to do is uncheck this image. I don't really like having this like default like rounded rectangle beneath my thing. I think it looks a little bit cleaner to just have it be text. But that choice is completely up to you. I'm gonna say click here to go to scene 1. And then I'm gonna change the vertex color to, how about a light red? This is a nice, like a pinkish red color here. So, kind of as an example of like responding on hover, I'm going to make it this actually. So, let me go to Piazza real quick. In the 494 Piazza, when this was suggested, the example that was shown, let me find it, by Max here was, enlarging on hover. I thought this is a great example, and I guess I'm going to show you how to do this one first. So what we're going to do, we're going to go to our button, we're going to add a component, and we're going to call grow on hover. Let's call that. Oh, sorry, I want to click new script and create an ad. And now I'm going to go, why don't I make this slightly smaller here? Let's go here. Let's go to grow on hover. So we want to do hover. So what we're going to do is we're going to first use this namespace here, Unity engines.event systems. We're going to say that we're using it. And then we're going to say I pointer enter handler and I pointer exit handler. And what that means is we're going to do when the user starts hovering on it and when the user stops hovering on it. These are the events that we want to get hook into. And you can see it starts giving us errors that we're not implementing the interface member that we're supposed to. So let's implement them. Public void on pointer enter pointer event data. And we want to do the same thing for on pointer exit. So now what else do we need? So we'll have public float default scale equals, or no, public float growth. We'll have that. And we'll have a public rect transform. Remember that a rect transform is the equivalent of a transform, but for our UI elements. And so now that we have these, what we'll do, on pointer enter, we're going to say transform.localScale equals vector3.1 times growth. And then down here, we'll say on pointer exit, transform.localScale equals vector3.1 time, it's just vector3.1 because we want to reset the local scale back to 111. If we look at the button here, its default scale is 111. So oh no, so let's call this button transform. So it's not yelling
Probably
at us.
don't even need to get the transform. You can just probably access transform.
You think?
That's how I did it.
But I mean, like, the thing is, transform will use it as like an actual transform and not a rect transform, and there's like inheritance that might go on, and I don't want to take advantages of inheritance in case something's gonna break, which I know is a bit protective of me, but like, might as well.
Also, I can't claim complete credit for it. I did take heavy inspiration from a Unity community answer or whatever.
That's fine. I'm not sure what that Unity community answer did, but hopefully what I'm doing is pretty similar to that so far.
Yeah. pretty similar.
Nice. Okay, so let's go back to our UI element. I'm gonna set growth. How about 1.3? And then we'll take the rect transform, drag it in, and I'm gonna hit play. And now, if I hover over the button, you can see it gets bigger. And when I stop hovering over it, it gets smaller. And that's pretty cool. We could go even further and do coroutines to make it, grow bigger and grow smaller. So we can get a public animation curve, growth curve, just as like a review of how the growth curves work. And because it might be fun. Growth curve, we'll say, we'll create a coroutine that we can use on both of these. We'll make a public I enumerator. What will you say? Go to scale or change scale of transform. It'll take in rect transform RT. Float start, float end, float duration. And then we'll have void return null. Right? No, that's not how that works. It's been a long day. Let's remember how coroutines works. This is your reminder that even your GSI can get lost on sleep. Yield return null, not void return null. At least it's Friday. Okay, so what we will do is sorry, let's go. Float time, float cur time equals 0f. And then we're gonna have our while cur time is less than duration. And we'll have cur time plus equals time dot delta time like usual, and then we'll have to have a yield return null at the end of our loop because that's how loops work in coroutines. And then essentially we can do the current time divided by the duration will be a proportion from 0 to 1 of where we currently are. Float progress equals cur time divided by duration. And then we want to get growth curve dot evaluate on progress. And this will give us the float that we want. And we want to do vector 3 dot lerp unclamp on vector 3 dot 1 times start, vector 3 dot 1 times end, and then growth curve dot evaluate progress. I've been writing a lot of code without testing, which is never a great sign, but for now, let's just try and use it on this side. Start coroutine, change scale of transform with button transform 1.0f, growth 1.0f. We'll make it go for, or why don't we make it go for 5 seconds just to make it really slow. Let's see if it works, or let's see if I introduced any bugs. Um, looks like it isn't doing anything now. So that's cool.
Do we need to add an animation curve?
That is probably what we need to do. Good call.
I don't know anything about animation curves, but
Yeah, let's make it this bouncy one where it'll start fast and then slow down. You're right. The animation curve being all 0 everywhere means that it's going to constantly be 0, I think. Uh-oh. That's not good. It's not working. Might be time to add a few debug logs. Let's just make sure first that we even get in here. It's one of those Fridays. Okay, so this works. It does get us in here. Let's pick something smaller. Um, we'll add that in, and I'm gonna hit collapse. So collapse in the console, if you're not familiar with it, if there are entries next to each other that have the exact same text, it'll just consolidate them into one item on the console, and then like show a counter on the side. Okay, so it is running the loop properly. Oh, you know why? You know what this is doing? We're just doing lerp without actually applying it to the rect transform scale. rt.local scale equals vector3.lerp unclamped. That's the big brain play right there. Oh, look at that. That's pretty good. And then 1 second's a bit slow. Let's make this 0.8. Um, let's use it here, and we'll go backwards. We'll go from growth to 1.0f. We'll make public float grow duration, and then we'll use grow duration, and we'll make that 0.8f. And then we can test it when we're out here. So let's make this 0.8. Now let's edit this curve a little bit, I think. I'm gonna make it go up a little bit. And make it go down, and then make it go up again. It's gonna go bouncy. It's gonna be weird and wacky and goofy. Let's try it out. That's pretty cool. Nice. Okay, so that's kind of an example of doing hover-based events to do responsive buttons. There's also click-based events too. So I'm not going to write the script for this for the purposes of time, but I already wrote the script for this. This is change color on click. I'll walk you through the code that I wrote though. So change color on click. What it does is similar to our I pointer enter handler and I pointer exit handler interfaces. We have down handler and up handler. So the thing with buttons in Unity UI, if you release your mouse and your mouse is still not hovered over the button press won't go through. So what you can do is you can take advantage of that sort of and make it so that when the player presses down, the color changes. When they release, the color changes back. This is like a nice, like another responsive thing to show that you're detecting the click. It just gives information to the player that the game does know that it clicked the button. So for this one, there is the one complication with this is that the text is down here in the inspector, and we want to drag this Text Mesh Pro object over to here in this. So I'm going to show you how to do that in Unity. It's a little bit unintuitive, but so the first thing you do, you click this lock icon up here on the inspector while you have the button view. Then you right click anywhere you want, click Add Tab Inspector. Then you go to the other thing. And now you can drag it in, and then you have like essentially two instances of the inspector doing different things. I'm going to close this tab out. I don't need it anymore. But that's a fun thing. I'm not sure if you're familiar with. Now let me copy this color here. I'm going to go to the button. I want the default color to be this. Also, another tip for you. I run into this problem all the time. When you add a public color to a script, its default transparency is always 0 for some reason. So make sure you set that to 1 so that it's completely opaque. Otherwise, you'll just be like, where's the color? There's no color, because it's all transparent by default. It can be annoying. So I'm gonna make it get darker on click and then get lighter again when we go back off of it. So before we use it, let me just show you again how this works. I just have my color and my text. On pointer down, similar to our on pointer enter, I just change the color, and then on pointer up, I change the color back. This isn't too bad of a script, but it does add some nice little juice. So now I'm going to hover. I'm going to hover onto it, and I'm going to hit click, and now you can see, oh, that's a bit dark. Why don't we make this a little bit lighter? I'm going to use. By the way, when doing this type of stuff, we talked earlier about color palettes. Just changing the value slider to get a darker and lighter version of the same color works pretty nicely. So I'm going to use that. I think that's not dark enough. All right, let's try that. So now you can see when I click, my mouse is down, the color is darker. When I release it, it gets lighter again. Right now, we don't have any click events attached to this button. So like clicking on it is going to be doing nothing for us. But we do have that working. Real quick, let me remove our console.logs so that we're not creating a whole bunch of output here. So that's pretty cool. I guess the next thing I will do, let's create a new scene. Let's create scene 1. And oftentimes in your menu, you'll want your button to just take you to a scene, right? Why does it look like a duplicate? Does new scene duplicate the scene you already have? Interesting. Let's remove the button here. Let's make this say scene 1. It's going to be italic. It's not going to be bold. We'll center it. Let's make it green. So now we know we're in scene 1. I'm going to go to the menu scene. And I already wrote this component as well, so let me show that to you. This is change scene on click. So a quick note about these Unity events with like the button on click. You can basically add any number of functions to run when the button gets clicked. And what you have to do if you write your own custom script for an event to occur on click, you have to write a script, add it to your guy. So I'm going to add our change scene on click script. And then I'm going to drag it in right here for the object it wants. I'm going to go to the change scene on click function. And the list of functions that are going to show up here are going to be public functions that are void return type and take in either an int, a float, a bool, or a string. If your function takes in anything more complicated than an int, a float, a bool, or a string, it's not going to show up in the dropdown here. But if you make it say a string, that's going to show up just fine. So in our case, I just have a public void change scene on click. It takes in a string target scene, which is the name of the scene, and I just call scene manager.load scene. So what I'll do, I'm going to go here, I'm going to change scene on click. I'm going to click change scene on click function, and we want to go to scene 1. So I'll type in scene 1 here, and I'll save the scene. And now here's our fancy UI element. We click, and scene 1 couldn't be loaded because it hasn't been added to the build settings. Of course not. Let's add open scenes. Let's also add scene 1 in here. And let's try this again. Huh. Why does scene 1 look like this? I thought we changed scene 1, didn't we, team?
Oh, you did?
Yeah, I thought so too. Whatever. Let's try again. Scene 1. Let's not make it bold. Let's make it italic. Let's make it green. Cool. All right, I'm going to save the scene. I hit Control S a bunch of times. Let's go back to the menu. Let's try this out. What the heck? This is not good. It's like overwriting what our scene is for some reason. Let's delete it. Oh, and it keeps on recreating it too? What's going on?
It might be something with the meta files.
That might be the case. Let's create a scene called ASDF. And ASDF will have our stuff. We'll just make it a different name completely. Let's put it down here. It's perfect. Go to build settings. We'll add the open scene. Let's delete that because it's a deleted scene. We want the menu scene to be in here. Okay. Oh wait, I need to now change this to take us to ASDF. The button. We want to go to ASDF now. This is great game design. Hey, and it worked. Nice. So let's summarize what we went through. The canvas. Make sure you pick scale with screen size. It's the first thing we went over. Text Mesh Pro. It's like text, but it is less blurry when you scale, and it has a lot more options exposed to it in scripts. So you can see I changed the color here. Color you can change on a normal text as well through scripts. But a TMP text object has way more abilities and functions, and you can check the docs for that, and that's cool. Also, you can use shaders with it, like screen shaders, so that's cool. The other thing we talked about was anchors. Anchors are the way that button or UI elements do relative positioning. They always are positioned relative to anchors, and so to take into account screen resizing, you want to pick the right anchors for your UI elements. Then finally, we talked about to hook into hover and click events on UI elements, you have to implement these interfaces by using Unity engine.event systems and then adding them and then creating the functions. Yeah, those were the things that we went over here. So are there any questions about what I went over? Anything else you want me to kind of talk about or mention? Any things you might want to try doing with your UI in terms of like fun interface stuff that you might want pointers on how to do? Anything like that?
I did have a question about the coroutine you wrote.
Oh, sure. Yeah. Why don't we take a look at that?
I just wasn't sure what the lerp unclamped does.
Okay, sure. I can explain that. So we talked about lerp in class, right?
Yes.
So lerp is short for linear interpolation. What it does is it's essentially this b minus a. All right, let's write it in a comment. B minus a. So like, let's say you're starting at A and you're going to B. And you're like 50% of the way there. you do 0.5 times b minus a over distance or something like that. I don't actually remember the lerp formula. Let's look it up. Yeah, that thing. But essentially what it does is it lets you, instead of instantaneously going from point A to point B, it smoothly like interpolates. It's like tweening, the idea of tweening in animation, where you have one frame and you have another frame, and then you kind of like do a slow gradual transform between the two frames. Lerp is that same concept where you have point A, point B, and you kind of smoothly translate between point A and point B. Unity has vector3.lerp, which lets you provide one vector3 and another vector3, and a float between 0 and 1 that indicates the progress that you've made so far. And it'll basically do this sort of distance formula thing where it's what is the point, like if we were going in a linear scale from A to B, what point in between a vector 3a and vector 3b would we be if like we were like float t away? So if t is 0.3, that's 30% of the way through. It'll calculate the vector that's 30% of the way between a and b. Unclamped is the same thing as that, except you can provide a value into it that's larger than 1 or smaller than 0, and it'll scale to that. With normal lerp, if you provide something that's smaller than 0, it'll make it 0. If you provide something that's bigger than 1, it'll make it into 1. And if we were to use normal lerp with our animation curve, you'll notice that our growth curve goes bigger than 1 up here. So if we were to pass that into normal lerp, it would scale it to 1, and instead of our thing growing past 1 and then coming and settling at 1 or at its target size, it would just reach its target and then get stuck at the target because it would be clamped to the maximum possible value it could be, which is vector 3b. Unclamped, on the other hand, lets you go past that, and it essentially what it does is, if you remember from algebra, you can create the equation for a line if you have 2 points. So essentially, it takes those the 2 points that you give it, and it creates the equation for the line. It says if x equals 0, the line returns the first point. If x equals 1, it'll return the second point. But in reality, it has the full equation for the line, and any number you pass to it, it'll return that point along the line. So in essence, we can now do like bouncy stuff. Actually, why don't I just show you? If I change this from unclamped into lerp, and more specifically, if I make all of the bouncy stuff be happening above 1, you'll now notice that when I hover over it, it just goes to the max that it wants to grow to, and it doesn't like go any further past that. But if I change this to lerp unclamped, then we can restart the scene. Now it can go past 1 or past 0. Does that make sense? I feel like that was kind of a rambly answer, so I apologize, but hopefully
yeah,
it was kind of
I
clear.
just didn't really understand how the lerp worked.
Yeah, so the lerp essentially it's calculating the equation for a line between 2 points, and then it says, if x is 0, it's the first point. If x is 1, it's the second point, and then it just literally picks the point across the line between the two of them. Cool. Any other thoughts or questions? If not, I can I can try to post these scripts to like a GitHub or something like that and link them in the description of the video for this, if people want them. But hopefully they're fairly straightforward enough that it would take less time to just write it yourself. So if you do want me to upload these scripts, let me know. Otherwise, I'll just assume that you're fine transcribing up the video. Otherwise, have a good weekend. Good luck with Project 3. And yeah, have a great day.